We're working with a dataset containing 100 samples, neatly divided into 10 groups. Each group has roughly 10 samples, although this might not be perfectly even. This is important because we'll be using a special technique called GroupKFold for splitting the data. I'll be using GroupKFold, a way to split data into folds while keeping samples from the same group together. Think of it like organizing a team. I want to ensure members of the same subgroup stay together in the different teams I'm creating. I'm making 5 folds, and the random underscore state ensures I'll get the same results every time, which is great for reproducibility. This statement says that GroupKFold ensures no 2 samples from the same group will end up in the same fold. This is a key feature of GroupKFold. It's designed to prevent data leakage. This is important, since the groups don't have exactly 10 samples each. It's approximately 10. Some folds may end up with slightly more or fewer samples than others. It's not a huge difference, but the unequal distribution among groups does lead to minor variations. This question asks us to identify which statements are true about our folds created using GroupKFold. This is just the title, indicating we're dealing with a cross-validation problem using the GroupKFold method. This suggests each fold would ideally contain about 20 samples, 100 total samples, 5 folds. However, this is not guaranteed with GroupKFold because it prioritizes keeping groups intact, even if it means folds are not perfectly equal in size. This reiterates the dataset characteristics: 100 samples in 10 groups, with approximately 10 samples per group. I'll divide the 100 samples into 5 folds. The key is, GroupKFold makes sure that all samples from a single group end up in the same fold. This prevents cheating by accidentally using data from the same group in both training and testing during cross-validation. Ideally, each of my 5 folds should have 20 samples. 100 samples, 5 folds equals 20 samples per fold. However, because I'm using GroupKFold and prioritizing keeping groups whole, some folds might have a few more or fewer samples than others. Because I'm focused on keeping groups together, it's possible that some of my folds might miss samples from one or more groups. It's not a requirement for GroupKFold to include every group in every fold. After this process, I will have 5 folds, ready to use for my cross-validation. Each fold will have samples from different groups. I'm analyzing a scenario using GroupKFold, a technique in machine learning for performing cross-validation. This is crucial when your data has groups, like patients in a medical study or users in a recommendation system, where you want to ensure data from the same group isn't split between training and testing. This helps prevent data leakage, i.e., accidentally using information from the test set to train the model. I have a dataset with 100 data points, samples, divided into 10 groups. Each group has roughly 10 samples, however, this number might vary slightly. Imagine these groups as distinct categories or clusters within the data. I'm using GroupKFold to split my data into 5 folds for cross-validation. GroupKFold is a special type of cross-validation that ensures all samples from the same group end up in the same fold. The !random underscore state is set to make sure I get the same results every time I run it, for reproducibility. This is the central question. I need to evaluate several statements about how GroupKFold has partitioned my data to figure out which ones are true. With 100 samples and 5 folds, we'd expect each fold to have about 20 samples, 100/5. But because GroupKFold prioritizes keeping groups together, this might not be exactly true. Because GroupKFold keeps groups together, it's not guaranteed that every fold will have samples from every group. Some folds might miss samples from certain groups. This is a core feature of GroupKFold. I absolutely guarantee samples from the same group will always be in the same fold. Since the group sizes aren't perfectly even, around 10 samples per group, some folds may end up with slightly more or fewer samples than others. This is completely expected. I have 100 data points, neatly divided into 10 groups. Each group has roughly 10 data points, although this isn't perfectly exact. This is important because we're using a special type of cross-validation. Think of it like organizing teams for a sports tournament. We want to make sure the teams are fairly balanced. If I divide 100 samples into 5 folds, ideally, Each fold will contain around 20 samples, 100 samples, 5 folds equals 20 samples, fold. However, because of how GroupKFold works, this might not be precisely the case. We'll get to that. I'm aiming for a representative sample in each fold. However, with GroupKFold, I prioritize keeping whole groups together. Therefore, it's not guaranteed that each fold will have samples from every group. This is the key. With GroupKFold, I make sure that no two samples from the same group end up in the same fold. This avoids data leakage, a big problem in machine learning. It's like making sure no player plays for two teams at once. Since the group sizes aren't exactly the same, they're approximately 10 each, the number of samples in each fold might vary a little. It's not a major issue. GroupKFold's goal is to keep the groups intact. These are the subsets created by GroupKFold for cross-validation. I'm creating 5 folds to test and validate a model. Each fold will serve as a validation set while the remaining folds form the training set. It's a process that helps me build more robust and generalizable models. This describes the overall type of problem we're tackling. We're using a specific technique called GroupKFold cross-validation. This method is crucial for preventing data leakage in situations where data points are grouped. I have 100 data points, and these data points are logically grouped into 10 different groups. Each group contains roughly 10 data points, but that number isn't strictly exact. I want to divide my data into 5 distinct subsets or folds, each used in a different way during the cross-validation process to evaluate the model's performance. This statement is about GroupKFold's core feature. Because of the grouping, the method ensures that data points from the same group always remain together and aren't accidentally split across different folds. That's critical for a fair and reliable model evaluation. Since the number of data points in each of my 10 groups isn't perfectly even, it's approximately 10 per group. It means the number of data points in each of the 5 folds is also not going to be exactly 20. There might be minor differences in the fold sizes. The question asks me to determine which statements accurately describe the properties of the folds generated by the GroupKFold method. This statement suggests that the number of samples in each fold will be around 20, based on the total 100 samples divided into 5 folds. 100/5 equals 20. But this might not be entirely true with GroupKFold, because the priority is keeping groups together. This statement says that every fold will have at least one data point from each group, which is often not true. GroupKFold's priority is to keep groups whole, not to guarantee every group is present in each fold. I'm dealing with a scenario using GroupKFold, a technique in machine learning for dividing data into subsets for cross-validation. It's specifically designed to handle grouped data. I have a dataset with 100 data points, organized into 10 groups. Each group contains roughly 10 data points. I want to split the data into 5 folds for cross-validation. I need to determine which statements correctly describe how the data will be divided into folds using GroupKFold. This statement says that GroupKFold will ensure no data points from the same group end up in the same fold. That's the core idea behind GroupKFold. It prevents data leakage. This means that because the groups might not have exactly 10 samples each, the folds might not have precisely the same number of samples. This statement claims that each fold will have samples from every group. This is false. GroupKFold prioritizes keeping groups together. Some groups might entirely end up in 1 or 2 folds. Ideally, with 100 samples and 5 folds, each fold would have around 20 samples. 100/5 equals 20. But GroupKFold prioritizes keeping groups together, so this isn't guaranteed. I'm using GroupKFold, a technique from the scikit-learn library, to perform cross-validation. It's a special kind of cross-validation designed to handle situations where my data is grouped. Think of it like separating students into project teams, ensuring no classmates from the same group end up on the same team. I have 100 data points, divided into 10 groups of roughly 10 points each. I want to split this data into 5 groups for cross-validation. This is important to evaluate how well my model generalizes. Ideally, yes, with 100 samples and 5 folds, each fold should have around 20. However, GroupKFold prioritizes keeping samples from the same group together. This can slightly change the fold sizes. This isn't guaranteed. GroupKFold's main goal is to keep groups whole in each fold, so some folds might miss some groups. Think of it like trying to divide project teams. You might not get all groups represented in each team. This is exactly what GroupKFold does. It's the core design, preventing data leakage by ensuring all data from a single group are in only one fold. Because the group sizes aren't perfectly even, some folds might end up with slightly more or fewer samples than others. It's like when you try to split equally sized items and don't end up with exactly equal distribution. The quiz asks me to determine which statements are correct regarding the way the data is split based on the use of GroupKFold. This is a good test of understanding of how this method works.